So let's go over some topics in trig. So as you may know, radians is a new way that we're going to use to define angles.
Yep.
So, but before we go on, let's talk about degrees. How do we define a degree?
Ooh. 1/360th of a circle.
Exactly. Yeah, that's pretty much it. So if we have a circle, that's a terrible circle, and we have a complete revolution angle within that circle, 1 degree is going to be 1/360th of that that angle. So we're going to split this up into 360 equal components, and that's going to give us our degree.
Yeah.
That's a really useful definition because 360 has a hell of a lot of factors. It has something like 1,000 of them. And it's got a lot more factors than any of the numbers near it. So it makes it really easy because we can divide it by 2, by 3, by 10, by 180, all sorts of things. So that's how we define it in degrees. But in radians, it's a little bit different. So with radians, if I take a circle, and let's say this circle has a radius of 1.
Yeah.
Then my other radius, let's say I have another radius here, goes out 1. And let's say the length of this arc here, let's say that is 1 unit long.
Right.
So let's say this is 1 meter, just for the sake of units, and this is also 1 meter.
Yeah.
Then the angle here is going to be 1 radian.
Right.
And that's our definition of a radian. So it's where the angle, 1 radian is where the angle of the arc is the same as the radius. So this works for a 1 meter radius circle. That's the most common example. Or if I had, say, a billion. Well, let's just go with a million because it's going to be hard for me to write a billion. And then I've got a million here. And the arc length is going to be a million. I'm just using a million because it's an arbitrarily big number.
Yeah.
And then that's still going to be 1 radian.
Right.
And so that's how we define a radian.
All right.
Right.
Cool.
So how many radians do you think there are in a circle?
Pi?
Not pi. You're really close.
2 pi?
2 pi.
Right. Yes.
So if I have a circle, so if I start with my radius and then I draw my circle out, then there are going to be 2 pi radians across this whole angle here.
Right.
And why is that? Because your circumference is equal to 2 pi r. So if we just look at our base case where r is 1, then our arc length is going to be 2 pi. Right?
Yep.
Yeah, and so we end up with 2 pi radians all the way through.
Right.
Does that make sense?
Yep.
And so for a semicircle, if we were to draw a semicircle out, we would have pi radians, which makes sense, doesn't it? Yeah. So from here, radians can be really important because now we're relating the angle to the arc length. And so when we're relating the angle to the arc length, we can use this in a variety of formulas that are really useful.
All right.
So let's, before we go on, so there's 2 pi radians in a complete circle. How many degrees are there in a complete circle?
360.
Yeah. So if we have 2 pi radians over 360 degrees, that fraction is going to be 1, right?
Yeah.
Yeah, because it's just different units for the same thing. So then it's going to be pi over 180 degrees.
Right, yeah.
This is our conversion for, this is this here, I should have that 1 in there as well. But that's our conversion for degrees to radians. So let's just say I had 30 degrees.
Mhm.
If I times that by pi radians over 180 degrees, then what happens? Well, my degrees cancel, and I just get left with radians all the way through.
Right.
So I get 30 pi over 180 radians, which gives me pi over 6 radians.
Yeah.
Yeah.
Yeah, cool.
So what do you think the conversion is if I had, say, 3 radians? What's the conversion to get me to degrees?
180 on pi.
Exactly. 180 on pi. Because that's going to be 180 degrees over pi radians. So my radian units cancel, and then I just get left with 3 times 180 degrees all over pi, which gives me a mess of a number. It's going to be, ooh, what is that going to be? 18 is 360, which then gives me 480 over pi radians.
Cool.
Sorry, pi degrees.
Yeah.
So as you can see, with radians, and when we're converting to and from radians, we're going to probably end up with a lot of pi's. That doesn't work. That's okay if we've got, say, 3 pi here, because then the pi's cancel, but sometimes you won't. So leaving it in exact value is definitely something we'll be after a lot.
Right.
Yeah. Does that make sense?